Hey guys, this is Landon Blake with Redefined Horizons. Welcome to the introduction for our workshop entitled A CAD System for Reuse and Parallel Work. I'm happy to have you guys for the workshop. It'll be about the next hour, hour and a half. So appreciate you tuning in to this. We'll let you know right up front, I'm getting over just a little bit of a sore throat, so if my voice is a little scratchy, that's why I'll try and make sure I speak loudly and clearly. And I wasn't able to record this in my normal studio location, so I'm in my home office, and you might hear my crazy Mexican wife in the background yelling at my dog, so I apologize in advance for that. Okay, so let me tell you a little bit about myself if you don't know me or you haven't caught one of my other workshops. So I'm a licensed land surveyor in California and Nevada. I also have my CFEDs. I've been surveying now for about 25 years, give or take, depending on how you count. I have always loved to draw. So since I was a little boy, I've always enjoyed drawing, and the whole reason I became a surveyor is because my local community college only taught one drafting class, and it was part of the surveying program. So I wanted to learn to be a drafter and didn't even know what a land surveyor was, and that's how I kind of fell into it. So I was drawn to land surveying because I love to draw. And I have used multiple flavors of CAD at multiple companies. So I've used AutoCAD products, including AutoCAD Civil 3D and AutoCAD Land Desktop, and Carlson Survey, and BricsCAD is what we use at my company, Redefined Horizons, and I've dabbled with MicroSurvey and some other CAD products. So I have seen CAD standards and CAD systems implemented in a number of different ways in a number of different organizations. So hopefully that'll give me the ability to approach this topic with you guys from a fairly broad perspective. So I'm hoping I can do that just based on some of that experience. Now I will tell you, disclaimer, I don't use CAD all the time anymore like I used to. So I am partners in a small land surveying business called Redefined Horizons, and I have a lot of other jobs. So I don't get to draw as much as I used to. That happens as you get older and get more responsibility in a survey organization. As I mentioned in one of my other workshops, I have a lot of really young, super smart young people that do most of my technical work now, including most of my drafting. So I don't get to use CAD as much as I used to, but I do have it. I still have it on my computer. You may actually see proof of that a little bit later if we get to open some CAD drawings, if we have time to do that. And I would say I'm in CAD at least a couple times a week, 2 or 3 times a week. So, and I still know enough to where I'm able to train people occasionally. I'll get time to do that, although I don't get to do as much of that anymore as I used to either. So this is an old guy teaching you about, going to teach you a little bit about CAD today. So what are we going to talk about in the workshop in the next hour and a half? So the first thing I'm going to do is tell you why I think this is an important topic, especially if you run a survey organization. I want to talk about that. I want to talk about just go over some definitions and some principles. So I don't know, I've got a half a dozen or so definitions that we can go over. I'm going to talk about the main parts of the CAD system that we're going to teach you today, which is it's our CAD system for mapping products, mapping deliverables at RH. So I'm not going to call it that. I'm just going to, for short, I'm going to call it the CAD system, but that's what it is. It's our RH CAD system for mapping deliverables. That's the technical name for it. So I'll talk about the main parts of that. Then we're going to look at a couple examples. I have a couple diagrams to just show you how we structure drawings as part of so we'll look at what we do for boundary mapping and then also what we do for topographic mapping. It's applicable to all kinds of other drafting, but we're going to look at those two examples because that's what we do the most of here at my company. And then if we have time, I would like to actually open CAD and show you what those drawings look like when they're layered on top of one another. And then I'd like to jump into Windows File Explorer and just show you how we structure our folders and files. I won't show you the whole project folder structure that we use here, job folder structure, but I'll try and go over the parts that are important for the CAD system. And then at the end here, I'll talk about some drawbacks of the system. It's not perfect. There are trade-offs, and you need to be aware of those trade-offs before you decide to implement something like this. And then if we still have time after all of that, I will go over some tips for implementation if you decide you want to try something like this. So what are we not going to talk about? We are not in this workshop going to show you how to do this in any kind of specific CAD software. I wanted to try and keep this software neutral if possible because I know individuals in my audience are going to be using lots of different CAD software. So at my shop, we use Carlson Survey and BricsCAD, two products I really enjoy and highly recommend, but most of the companies I've worked at used AutoCAD Civil 3D, so I've done this in something similar to this in AutoCAD Civil 3D. I'm also not going to tell you in this workshop the other ways to organize your CAD mapping. There are other ways to do that. We'll talk briefly about that in one of our definitions, but this is a one-trick pony today. We're just going to learn about this one way to do it. And this system that we're setting up was really designed to enable reuse and parallel work. So that's what the focus is going to be on, and we'll talk a little bit more in just a few minutes about why we ended up doing that at my company at Redefine Horizons. So let's talk for a minute about why this is important. So I have a few reasons why I think this is important. And if you watched my other recent workshop about field to finish, some of this will sound familiar because there's a couple common points here. But the first reason this is important is because it reduces errors. So I think it improves the quality of your work products, and for us that's really important. It's important for my company and my team because we are not the cheapest land surveyors, so we don't compete based on low bid or low price, and so it's really important that we deliver a quality product, and so this system helps us to do that. It also saves both time and money, which is important. So we talked in my other workshop video about, it's important that we be productive and save money in our CAD work because we tend to pay above market rate for our technical staff, and not a little bit. It's a significant. What I feel like it now, I'm biased because I'm one of the owners, but I think we pay 10 to 25% above market rate. So we have to be productive to make up for that, and this CAD system helps us to do that. It also saves us time, and we're going to talk about that some more. But this enables reuse and parallel work, right? Both of those things save you time, and that was really important to our company, especially the first couple of years, because of the business model. It's still important, but it was really vital for us then, and I can talk about that a little more in a minute. I think it makes training easier, which is, again, that's important for my team because of the business model we run. So we are typically hiring folks, especially on the CAD side. Though most of the folks we hire are entry level, so they may like to draw or have a little bit of maybe some graphic design or art experience when they come to work for us. Not necessarily, but almost none of them have formal CAD training or even know how to turn CAD on. And so we hire those people and teach them to be really great mappers and drafters. So this system, I think, makes training easier because it allows a new CAD tech to start with some very simple pieces of the overall deliverable to the client, and so that makes training easier. It also makes it easier for us to fully utilize our people, and if you've run a surveying business or organization, public or private, you know that utilization rates are important. Now that is not something we obsess over here at my company. We don't make a concerted effort to track utilization rates. My folks don't have a minimum utilization rate, but we are conscious of it and aware of it. And one of the things that's really beautiful about this system that enables parallel work is it allows us to keep our survey techs fully utilized because they can hop. If one project slows down or gets iced for some reason, gets paused, they can hop over and help one of their coworkers with one of their projects, and it's fairly easy to. I'm not going to say it's seamless, but it's easier to do that than any other system I've seen. And so, of course, when you take all those things and put it together, that also makes us more profitable, right? Which is important because we pay above market rate and we do really good work, which is sometimes expensive. Having a little more room in the profit margin allows us to survive as an organization. So, for all those reasons, I think this is important. So the last thing I wanted to cover in this section of the workshop is why we did this. So I'm not sure that I set out with a master plan to do this when I started the business, and I don't think my partner Danny did either. My partner that helped me found the company. So this just kind of happened somewhat organically. Now I had thought through parts of this system at other employers, but never had the chance to implement it. So when I started my own business, I finally had the chance to do some of this, but the whole system and the pieces didn't really come together as part of any kind of master plan. I wish I was that smart, but I'm not. So we have discovered some of this just by stumbling. But it was really important for us in the beginning, and it was kind of vital to the way our business was run the first couple years. And there was a couple reasons for that. One was the first couple years we were in business, the whole way we managed to win clients was by promising and then delivering in really incredible time frames. So time frames that I had never seen at any other surveying company I'd worked for. So we could turn a full Alta survey around from notice to proceed to preliminary survey for review by the parties in the transaction. We would do that somewhere between 5 and 15 days, depending on the size, and it was often closer to 5 days than it was 15. We don't do that as much now as we used to because our mix of work has changed, but we did a lot of that in the first 2 years, and we still occasionally will do that. If we have a client that we've worked with previously that calls here and is in a hurry and is willing to pay for the rush, we can do that. And so this whole system was that we're going to talk about today was designed to enable that. When you're trying to turn a full Alta around in 5 working days, you do not have the luxury of parking that on one person's desk for the duration of the project. So you need to be working on multiple parts of that deliverable at one time. And so that's what this system was really made for. So fast delivery of a quality mapping product. And that's why we built this. And that you heard me use that term innovation stack. And that's not my term. There's actually a gentleman that wrote a book. It's a really good book. It's one of the best books I have ever read. So I encourage you, if you like business books, to check this out. It's a audible book too, but it's called The Innovation Stack. And it's a super good book. So I wanted to just share that with you guys. If you want to geek out on some more of this kind of stuff. But the basic premise of the book is if you're going to build a unique firm, you're going to have to invent some things, and then when you invent some things, that creates some problems that requires that you invent some other things. And so that's kind of the process that we've gone through here at Redefine Horizons. My partners and I, and we've had a really great CAD tech. Her name is Elena, that has been with us from the very beginning, almost the very beginning, that has helped us with that. And another one of our folks, Austin, has been with us from the very beginning. It was my first employee. And so they really helped us build and flesh out this system. Now, I will tell you, some people, when they hear me teach, they think they kind of take me the wrong way a little bit. And they say, oh, that guy, he just thinks he knows everything. I don't. And this system that we have at my company is not perfect, and we're always working to improve it. And we've been using it for 5 years, and we still have a lot of work to do. And that's, I've got a great team with really smart people, and it's still, there's a lot to do here. And I said in my other video on Field to Finish, I don't know that you ever finish this kind of system. I think as technology's changing and you're doing different kinds of work, you're always making tweaks and improvements. So by no means do I think I have this all figured out. I don't, but I'm really excited to share with you guys what we've done here. I think I've never seen anything like this at any other places I've worked. if you have a system like this, I would love for you to reach out to me, and I'd love to talk to you about it. I'm sure I could learn things from you if you're doing it. So I'm not saying that there aren't other mapping organizations that do something like this, but I've never seen one or worked at one. And I'm a hothead, so I've been a lot of different places. I haven't seen this yet. So we're really proud of this system. Now, one thing you might be wondering, and I'll wrap up this section of the workshop, but one thing you might be wondering is why would Landon, teach this workshop and share with a bunch of his competitors this is, I would call this a key part of our innovation stack, right? So this is a really important part of the way we work, and I think it does give us a competitive advantage. So why would I share that? Well, there's a couple reasons that I'm comfortable doing that. One is you can hand somebody a recipe for a great meal, but that doesn't turn them into a gourmet chef, right? So just having the recipe that I'm going to give you here doesn't mean you can just go do this tomorrow. So this requires a fundamental and change to the way that you work. You could call it a structural change. So it's not something that you're just going to go try for a few days, because it changes everything about how you do your mapping work. So it's not easy to implement. It takes a fundamental change. And to be honest with you, I don't know if I could have ever done this at an existing organization, brought in this kind of system. One of the reasons we were able to do this is because I was able to do it from scratch, right? I'm not saying you can't do it at an existing organization. I think you can, and I hope some of you that listen to the workshop will try to do this at your organizations. But it's a major undertaking. So I'm not super worried. Very few of you are going to listen to this workshop and then run out and try this tomorrow and have it work perfectly. I've been doing it for 5 years, and we still don't have all the kinks ironed out. So that's one reason. The other reason is, one of the things we try and do at Redefine Horizons is really improve the practice of surveying as a profession. So I always tell people I don't mind losing work to good firms. I understand that we're not a great fit for every project and that we're not going to win every project. What I do mind is losing work to garbage firms, and there's a lot of them in our profession. I don't think we're always honest about that. So there's a lot of people doing really crummy work, and so I hope that the folks, typically if you're at a conference or another event listening to a talk like this, you care a lot about what you do, and so those are the kinds of people that my partners and I are trying to help. So I hope I can help some good surveyors here think critically about the way they organize their CAD drawings and do their work. And we would love it if more people implemented this system, and I would absolutely love to hear from you if you have questions about this, or if you implement this and have questions or criticisms or comments, because it's going to make my team better, and we would love to collaborate with folks on this. So I'm excited to share it with you, and I'm not worried. I'm not worried if you also run a small surveying shop. It's okay. I want you to take these ideas and hopefully be able to use them. And the other reason that I like to do this is so much of what has helped me run this business the last 5 years, I was taught by others, including at conferences and events like this one. So I feel some obligation to try and pay that forward, and I think that's an important part of being a licensed professional. So I hope you guys enjoy this, and I hope some of you geekier folks that are watching get excited about this. I'm excited to share it with you. I know it doesn't sound like I'm excited because I'm getting over this cold and fighting a little bit of a sore throat, but I was excited to be invited to talk about this particular topic. So that's going to wrap up the first section of the workshop. What we'll do in the next section is we're going to go through some definitions and principles, and probably talk about the main parts of the system. We can do that together. So that'll be in the next section of the workshop here. So just hang tight. Okay, guys, ready for this next section of our workshop here. I switched my recording of my screens around a little bit, so hopefully you guys will see more of the front of my face and less of the side of my ugly face. Hopefully you're not looking at my face, but if you are. So in this part of the workshop, I want to just talk about a few definitions of some some important terms, and then just a principle. We'll talk about a principle that we use in the design of the system. And there'll be some other definitions too as we get into this to the workshop, but I wanted to cover a few right in the beginning. So that the title of this workshop is a CAD system for reuse and parallel work. So what do I mean when I say reuse? So in this context, reuse means the repeated use of base drawings and sheet elements. And so we're going to talk about that. So the goal is to reuse as much of your drawings as you can, as when you're not just across projects, but primarily within the same project. And certainly we're going to talk about how we do that with what we call base drawings, which is a term we'll define later. But I'm not sure if we'll have time to get into how we reuse sheet elements. I would like, if I have time, to show you guys how we set up our layout grid and how that allows us to reuse sheet elements. But I'm not sure if we'll have time. If we do, I would love to do that. If we don't have time and you guys are interested in that, if you jump on the Redefine Horizons Learning YouTube channel and look at our CAD playlist, you'll find some short videos. They're usually about 10 minutes. Some videos there about our layout grid and our text baseline grid. So that's what I mean by reuse. It's being able to use base drawings and elements of sheets across the deliverables for the same project primarily. What do I mean when I say parallel work? CAD system for parallel work. In this context, what that term means is that multiple people can work on drawings for the same project at the same time. And under a traditional CAD system, like those at many of the places I've worked, that's not possible. You get one person in the project drawings at a time. Maybe you could have somebody working on a topo while somebody else was working on a boundary, maybe. But in our system, the system we're going to talk about, I can have 3 people working on a topo, the same topo, or 3 people working on the same boundary, conceivably, multiple people. So I could have, 3 people working on the boundary and 2 people working on the topo, right? And another person working on the sheet drawings. So that's what I mean by parallel work, and that's really the power of this system. You guys will remember in the first section of the workshop, I talked about, this is a system we developed out of necessity because we were just doing some incredibly fast turnaround times in the first couple of years that we had the business. Okay, what do I mean? What do I mean when I talk about CAD standards? And you guys notice I haven't been saying CAD standards; I've been saying CAD systems. So how are those two things different in the context of this conversation that we're going to have today? So when I say CAD standards, and I won't use that term very often, but if you hear me say that, what I'm talking about there is the rules for the appearance and structure of elements inside of an individual drawing. So that's what I mean by CAD standards. What fonts do you use for map labels? What font do you use for road name? How big is the text for a road name? What kind of line type do you use for a right-of-way center line? What kind of line type do you use for an easement? What layer does the easement line work go on? Those are what I call CAD standards, and we have those. We're not going to talk about them today. That's a whole other workshop, but we have CAD standards at RH. They could be better documented, as I'm sure they could be at many places. That's on our to-do list. But that's not most of what we're talking about today. So most of what we are talking about today is a CAD system. So how's that different from CAD standards? So CAD system is the guidelines for the relationship between drawings that help create and or are part of a mapping deliverable. So in my mind, CAD standards are more rules for about what appears in an individual drawing, and a CAD system is the guidelines or rules for how drawings are structured and related to one another, how they connect. And that's primarily through uses XREFs, which we'll talk about. Now, you're also going to hear me a little bit talk about drawings or drawing entities that are what we call scale dependent, and that's a very important part of our system. So when I say something is scale dependent, what do I mean? Scale dependent means a drawing or drawing elements with appearance that is dependent on the scale of the ultimate mapping deliverable. So hatch, blocks, text, primarily. Those are things that are scale dependent, right? What is scale independent? Those are drawing elements that whose appearance doesn't fundamentally change even if the scale of the mapping product changes. And so that's primarily line work, but it could be other things. An orthophoto, for example, is scale independent. Now, this system is not always black and white. So I know some of you are saying, well, line work can change if it's got a dashed line type to it. That will change depending on the scale. And that is true. What makes that a little bit different from some of the other elements is it's fairly easy to change all of the line work. It's fairly easy to change the line type scale for all of the line work in a drawing with a single environment variable, whereas text and hatch and blocks are not. They do not change as easily. So that's one of the reasons why. You'll hear me refer to line work as scale independent rather than scale dependent. And then the other definition I want to talk about, and we're not going to go into detail on this, but I want to just mention it because I'm going to contrast this system to this system I'm about to define. And I call that the bucket method. And if you've ever watched any of my videos on YouTube about file management, it's a similar principle. So what is the bucket method? That's when everything you need for a mapping deliverable is in a single drawing. Everything. Line work, aerial imagery, text, dimensions, hatch, symbols, the sheet. You got one master drawing. And most of the firms I have worked at follow that model. Now, sometimes the sheet will be in a different drawing, depending on how companies set things up. But most of the companies I've worked at use the bucket method, right? So everything for the topo is in a single drawing. So that is the opposite of the system that we're going to talk about today. So we do not use the bucket method here at RH. And I'm not saying you can't use the bucket method. The bucket method is perfectly fine for a lot of things. In fact, we do a fair amount of corner records, and because they're fairly simple and not very complex, that is one thing that we depending on the type of corner record it is. For those of you that don't know, in California, corner records, it's basically a one-sheet document. It looks like a plat, a little bit like a land description plat. But if we have a really simple corner record where we're just showing a couple swing ties to one monument, we might use the bucket method for that. But that's probably the only thing in my shop that the bucket method system would be used for. So let's talk about the main parts of the system next. Let me find that slide, guys, real quick. So I want to talk about what are the main parts of the system. And I've got a little diagram here we'll look at in a minute. But let me verbally describe it for you. So the system is basically made up of 4 types of drawings. So those drawings are what we call base drawings. Base drawings are used across mapping deliverables in a job. So they're shared across mapping deliverables. And so we have 2 or 3 types of base drawings. We have line work drawings. We have what we call scale dependent point drawings. So that's a drawing where we've labeled points. They have a label at a specific scale. And we have what we call annotation drawings, which is dimensions and text. Typically could also be blocks, block symbols. So those are our base drawings. Then we have sheet drawings. And I don't know if we'll have time to get into detail on how we do our sheet drawings, but it is important, and I want to let you know that we have a rule at my shop. It's 1 drawing per sheet. So if you have a land description plat with 3 sheets, you have 3 sheet drawings. If you have an Alta survey with 7 sheets, you have 3 sheet drawings. So we do not put more than 1 layout tab in a drawing. And the only thing, typically, that goes in the model space of a sheet drawing are XREFs. So the only thing in the model space of a sheet drawing are the base drawings. That's it. Now, on the sheet itself, we do have things like our legend and our standard notes and the title block. But that's all in the paper space tab or the layout tab. Okay, it's not in the model space tab. And we have some pretty strict rules about what kind of text is allowed to be in a base drawing and what kind of text is allowed to be in a sheet drawing, and we follow those rules pretty religiously because it's important for the way our system is set up. The other part of the system, so we have base drawings, we have sheet drawings, we have what are called master drawings, and that's not something we had early on, but it's developed as basically as a response to a client need. And so we don't do a ton of work for architects and engineers just because of the type of business that we run. But when we do work for architects and engineers, a lot of them aren't looking for a sheet. They just want a drawing that they can XREF into their sheet drawings. And so what we've developed to do that is what we call a master drawing. So that's a drawing. It doesn't have a sheet or a layout tab in it, but it has all of our XREFs overlaid in the proper order. It's purged, and it's cleaned up. It's properly layered. And so you can think of it almost like a sheet drawing without an edge to the paper, right? And everything's in model space, but the engineer or architect can XREF that into their design drawing. So that's what we call a master drawing. We do include some standard notes in those. They're just in model space. And then we have what I call support drawings. So those are drawings that don't appear in the final deliverable, but are used, are created and used as part of the process to make the final deliverable. And we'll look at that. We'll look at some examples of that a little bit later in the workshop. So those are the four main parts. Okay, just to review: the base drawings, the sheet drawings, the master drawings, and the support drawings. And I have a diagram that shows that for you guys. So here it is. So base drawings, sheet drawings, master drawings, and support drawings. And when we get to a little bit later in the workshop, we're going to see examples of this. I have a couple diagrams we'll look at for topographic mapping and for boundary mapping. And then if we can, we'll get into CAD, and I'll show you how those work in a drawing. The layered XREFs work. The other thing I want to point out right here is this structure right here. This is the system. This structure works for all kinds of different mapping. So if you do flood mapping, it could work for that. If you do, the interior of buildings, if you're a structural engineer, whatever your thing is that you draw, this kind of system will facilitate that. And what you'll see as we get into the examples with the boundary mapping and the topographic mapping is this is kind of like the core or the base, the minimum. And then as you develop this system a little bit for the different types of mapping you do, you'll see some different types of drawings get added to this diagram of the same type. They're all the drawings that get added are one of these four types, but you'll see as you develop this system, you kind of fine grain that this gets a little more fine grained, a little more granular, and we'll look at some examples. So that's how this works. That's the basic parts of the system. Let me check my outline here and make sure I'm not forgetting something, guys. Give me a minute to look at this. Okay, so I think we're ready to go ahead and dive into the first example, which is going to be the boundary mapping example. So I'm going to go ahead and in this section now of the workshop, and I'll be back in a flash. And we'll look, what we're going to do is we're going to look at the diagram first, and I'm going to try and carefully explain that. And then I'm a little scared, but we're going to jump into CAD and go look at an actual project that we did last year. And in theory, I will show you how this works. So we'll see how that goes. So, all right, we'll come back. We'll look at the diagram for the boundary mapping example. All right, guys, I'm back. Hopefully you're still awake. I apologize. My voice is starting to get starting to get a little hoarse. So I'm going to try and talk loud. Just be patient with me, please, and I'll try and get through this next 45 minutes or so. Okay, so I have, hopefully you can see on the screen there, I just have a diagram for how would this work, for example, for boundary mapping. And so you can see I've kind of color-coded the drawings there. In this example I've got, and the particular set of drawings will change depending on the mapping deliverables and the project. But in this particular example I've got, let's say we're going to do a boundary survey, and then we're going to create a plat and legal for a lease parcel. Okay, so how would our drawing, what would our drawing structure look like? So we have two support drawings in this scenario. You can see those in gray. So that would be our COGO drawings. So that would be deeds or maps that we COGO that we draw up as part of our boundary resolution. And then the way we do that at our shop is those drawings get put into as blocks per record. They get put into what we call a boundary search drawing, and that's typically what we use as the basis for our search coordinates. Once we found a few monuments in the field. So this is, now there's some rules about this, right? All the drawings, so these get inserted as blocks into the boundary search drawing, and everything in here has to be record. So we know everything in there is record, and they're all anchored to either each other, to found monuments, or to each other. Okay, once we've done that and we've recovered all the field evidence that we need to recover, then we go in and we have a process whereby we go in and we actually resolve the boundary. So we may not hold record, right? We may hold measured, or we may hold some calculated values. So we do that. The end result of that process is what we call a boundary line work drawing. And the boundary search drawing can get a little bit messy because you have overlapping lines. The boundary line work drawing is very much not like that. So it's very clean. So there's only one representation of each boundary line, each boundary segment, arc, or line. Everything's layered properly, and this is, when this drawing gets finalized, that's it. That's where we think the boundary is. Now, a lot of people, a lot of folks that know me and follow me don't always agree with the way I resolve boundaries, but the point is there's a process to get from the boundary search drawing, which is essentially record, to the boundary line work drawing, which could be a combination of record, measured, and calculated. Okay. So now let me just explain. In the COGO drawings, we do label the bearing and distances, but that's only used to check the COGO. Okay. Those bearing and distance labels don't show up in any of the mapping deliverables. And the same thing with the boundary search drawing. That never goes to the client. The client never sees that. That's why we call it a support drawing. It's for our work. Okay, now the boundary line work drawing is different. It's what we call a base drawing, because that line work may show up in multiple mapping deliverables for the same project. So in this example, let's just say we were doing an ALTA survey of the parent parcel, or a record of survey of the parent parcel, in addition to the lease plat. The boundary line work drawing would show up in both the record of survey sheet drawing and the lease plat sheet drawing as an XREF. Okay, so the reason we do that is there's one drawing that is the authoritative source for all of the boundary line work on a job at my shop. You don't go to two places ever. In fact, if I catch you making copies of the boundary line work drawing, you get your fingers cut off. Like you lose your pinky finger first, right? Because we want our folks to always be able to know that the version of the boundary line work drawing they have is the authoritative, up-to-date version, right? So let's just say, for some reason, something in the boundary line work drawing changed. That would be unusual, but let's just say it did. That change is going to water through all our mapping deliverables because it's an XREF, and we set the system up that way on purpose. Now, you may be thinking to yourself, well, what if you need a record of what maybe you sent one of those drawings out and you need a record of that. That's okay, because whenever we ship drawings to a client, the XREFs that go into that, either master drawing or sheet drawing, are bound into that drawing that gets delivered, and that goes into a specific folder with the date and client name. So we always have a record of what's sent. Okay, but I don't want my folks creating new mapping deliverables with out-of-date line work. So that boundary line work drawing is, to some extent, it's sacred, right? After I finish the boundary resolution, you better not be moving stuff in that drawing, and you better not be making copies of it. That is a big no-no. Okay, so that's a super critical drawing. Now, the boundary anno drawing is also a base drawing. It's not as important. I mean, it's important, but it's not as critical as the boundary line work drawing. The boundary anno drawing has all our bearing and distance labels, record versus measured annotations, our block symbols for our found, set, search not found, property corner monuments, map names, road names, owner labels, deed references, everything that you would expect is in the boundary anno drawing. Now, the way we set our boundary anno drawings up is there's one, and this is true for all of our anno drawings, so it's not just boundary anno drawings. There is one anno drawing for each scale that we are going to work at in the job. Now, we do everything we can to stick to 2 scales. So we have kind of like an overall wide project view scale that might be 1 to 500 or 1 to 1,000 or 1 to 2,000. And then we typically have the main mapping scale, which is going to be, at my shop, it's usually 1 to 20 or 1 to 10. It might be 1 to 40 if we're doing a larger rural parcel. And that's it. We try not to have more scales than that, if at all possible. In fact, we'll use a detail before we add a scale. Now, sometimes it cannot be avoided, and we have to add a 3rd or a 4th scale to a set of mapping deliverables. But if we do that, they will get their own anno drawing. And we actually, the way we name the anno drawing, you'll see this when I get into CAD. The way we name the anno drawing, the last part of the anno drawing has the mapping scale. Okay, so that's what's in the boundary anno drawing. So the boundary anno drawing is made to overlay on top of the boundary line work drawing, which means if for some reason you have, let's say, a boundary anno drawing at 1 to 40 scale and a boundary anno drawing at 1 to 1,000, both of those boundary anno drawings will properly lay over the same boundary line work base drawing. That's how they're made. Okay. Now, in this particular example, because we're going to do a lease, we have what we call boundary design drawings. So what goes into a boundary design drawing? That's all the lines, the boundary lines, could be easements, leases, fee parcel lines that don't exist yet. In other words, they're proposed, right? So in this case, the boundary design line work drawing would have the lines of the lease parcel. And that's it. That's the only thing in that drawing. It's just the lease parcel lines. And again, for the same reason, right? There could be changes. That location of that lease parcel could change over time as we're working with the client. Working with the client and the engineer and the architect, whoever. And so same rules apply to that. You don't get to make copies of that. And if you're going to go in there and change something in that drawing, you better know what you're doing. Okay, so remember I told you this system helps make training easier. One of the ways it does that is, if you've only been a CAD tech at my shop for 6 months, you're not allowed to go in and mess with the boundary line work drawing or the boundary design line work drawing. You don't have you don't have security clearance for that, right? So now, my CAD techs that have been with me for a few years, my survey techs, Austin and Elena, they can go in, for example, I might work with them. They might be allowed to do some things in a boundary design line work drawing or a boundary line work drawing, but as a general rule, I, as a licensed surveyor, am going to know what's going on. Now, I don't have to worry about engineers or architects because we're not a design firm, we're a survey-only firm. But if you are a poor, tortured surveyor soul that works as part of a design company, which many of you will be, the other nice thing about this system is it allows you to have a little bit of a firewall between your survey side and your design side. So you can set your file servers up to where the engineers and the architects don't get editable copies of your boundary line work drawings. They might only get read-only copies. All right, so in this example, the blue drawings there are going to be what we call base drawings, so they're going to show up in the deliverables. And then the green drawings there, the green drawings are going to be what we use for the actual mapping deliverables or the work products. And so we might have a drawing that has some, I call it a plat anno drawing, that maybe has some specific annotations that only belong in the lease plat. That doesn't always happen, so we don't always need that. But occasionally, you get some things you can't keep them in the boundary design anno drawing. You need something specific to the plat, so it will go in that drawing. And then we actually would have a sheet drawing for each page of the plat. And normally we have at least 2 pages on a plat, so there would be at least 2 pages. Now the other thing I will tell you is that these drawings live in different locations. So the COGO drawings live in a folder, then these boundary drawings here live in another folder, and then always all of our sheet drawings always live in their own, and we have what we call mapping folder. And hopefully I'll have time to show you that a little bit later in the workshop. So that gives you an idea of how this system works. I wanted to try and make it a little more concrete, not so abstract. I know it can be tough to wrap your brain around a little bit, but hopefully it's a little more clear with an example. I am going to just pause this video, and then when I come back, we're going to see, I'm going to, in theory, show you this in an actual job that I did up near Sacramento a few months ago, and you guys hopefully will be able to see how this works. Okay, guys, my wife fed me some leftover pizza, and I'm ready to dive back into this workshop. So I want to show you what this system actually looks like in CAD. And again, I'm not trying to promote any particular CAD system here. This works in multiple flavors of CAD. So I have the boundary folder open in this job that we did up near Sacramento, and you can see the drawings here. So in the Kogo folder, we have our Kogos, one drawing per document, and then we have our anno drawings. So in this particular job, we have 2 scales that we're working at, which is, like I said, we try and keep it to a minimum of 2, or to a maximum of 2. So we have a 30 scale anno drawing, and we have a 60 scale. Okay, so we ended up. This is our overall 60, and our regular working scale is 1 inch equals 30. You can see we have our search drawing here. We have our line work drawing here. This has a W on it, which means it's still working. It hasn't been finalized yet. I'm waiting on some information. The city paved over a half a dozen centerline monuments, so I'm waiting on some information to finalize this. But we didn't talk about this, but we have a drawing that we use to calc points for staking, so to set the monuments. So that would be an example of another support drawing. So let's go ahead and pop open BricsCAD here. So this is our boundary search drawing, and as I said before, these get a little bit messy. And you can see we've got the labels from the Kogos are in here, and these get a little ugly. They can be cleaned up a little bit, but they get kind of ugly. And you can see, we've got doubled lines there, so I've got 3 or 4 different versions of that line depending on where the maps are anchored and rotated. And we've got our points in. So we shot some fences. We always try and check occupation when we do a boundary. And there's a little creek running here. We shot the top bank of the creek, and some fences and some monuments. Okay, so let's look at the boundary line work. So this is the search drawing. This is not a deliverable. This is not a deliverable drawing, and it's also not a base drawing. It's what I call support drawing. Well, let's open the boundary line work drawing. So you guys can see that. So here's the boundary line work drawing, and as you can see, it's much cleaner. And we only have one line representing every segment of the boundary. So this is actually our subject parcel here, the shape, and these are adjoiners. So this is kind of our resolved boundary matrix on this particular survey. I have a video on my YouTube, a couple of videos that talk about the resolved boundary matrix, and these are all layered. So this is the subject fee parcel, and these are the adjoiner lines, and then we have some PLSS section lines in here, and we've got some tie lines. So this is all set up, and you can see there's no text, dimensions, or block symbols in here. This is just line work. Now what that means is we can reuse this for multiple products. So I've got a client here that we don't typically do this kind of work, but this is a friend of a friend, and he bought this vacant lot, and he's building a custom home. So right now the deliverable, I think we gave him an existing conditions exhibit, but I need to do a record of survey, and we may end up helping him do a site plan for this. So we could have 3 different deliverables that all use this same line work, right? Which is the point of the. Sorry, my nose is itching a little bit. It's the same. It's the point of the system, right? To have one authoritative line work drawing. Now let's open the anno drawing, which is going to look weird, the boundary anno drawing, but when I do the overlay, you'll see how this works. So let's open up that anno drawing. So I'm going to open up the 60 scale. So let's start with that. So that's kind of our overall scale. So here's the anno drawing, and you can see it only has text, dimensions, and symbols. So it's got our crow's feet, and these are our set monument symbols. There's no line work in here. It's got the road names. Now this looks weird by itself. We just got a text display issue there. So this looks funky, right? But watch what happens when we do the overlay. So, and the way we actually do this is the line work drawing and the anno drawing get XREF'd into it to a new drawing, but I'm just going to go ahead and insert the line work drawing into this drawing that we have open. So we'll go ahead and grab that, and we're just going to drop it in as an XREF. And so you can see all the annotations are set up to just lay right over that line work. Now how do we do that? Well, the way we do that is we draw, when we go to prepare the anno drawing, we XREF in the line work drawing, and we actually draw annotations with the line work in the annotation drawing, just like I just did just now. Now you might say, well, what's the point of all this? Well, part of the point is if we do a site plan, the site plan and the record of survey and the existing conditions exhibit are going to share most of these labels here on the boundary. Now the site plan may have some other labels, but certainly the existing conditions exhibit and the record of survey are going to share almost all of these labels. All right, so that's how the basic system works. Let's go in and let me pause the video, and I'm going to go in and we're going to take a look at, I'm not sure if we have an actual work product drawing I can show you, but let me pause and we'll take a look. Okay guys, so I do have a couple of work products. I'm not sure if we started the record of survey. It looks like we did. So we did start on the record of survey a little bit, but that's still preliminary. But we did put together an ECE for the client. So just so you guys know, I'm now in the mapping folder. Okay, so if you remember earlier in the workshop, I told you in our system, that's where we keep all of the sheet drawings. They're in the mapping folder. And then typically in the mapping folder, we will have a folder for each mapping deliverable. So this is our existing conditions exhibit. This is our record of survey. We have a folder in here for the UAV aerial. So let's pop open the ECE, and then we're going to take a look at a couple of these sheets. So you remember earlier we do a separate drawing for each sheet. So there's only one layout tab per sheet. So here's sheet 1. And you can see there's nothing in the model space drawing except for the XREFs. So I have the line work drawing and the 60 scale drawing. That's all that's in here. There's nothing else in the model space. And then on our actual sheet, we have our title block and the viewport, and we have our legend, our references, our abbreviations, but that's it. Now we have a second sheet on this because what we did is we ended up doing kind of an overall that showed the resolved boundary matrix, but then we wanted to do a zoom in. We wanted to zoom in the scale on the actual subject parcel for the client, so we ended up doing 2 sheets. So let's open that other sheet drawing. So here's sheet 2. Okay, and it looks like we had the UAV ortho turned on in this sheet, and I just on my home computer that path is broken, but so you can see same system here. We have the UAV ortho in here, but you'll notice in this drawing we have the same line work, but it's the 60 scale anno. In this drawing, because we're at 30 scale, we have the same line work drawing, but the 30 scale anno. So the 30 scale anno is not the same. So we can open up the 30 scale anno and just look at it. Okay, so here's the 30 scale anno, and you can see it's quite a bit different than the 60 scale, right? Because we're not showing everything in the resolved boundary matrix. We're resolved in here on the subject parcel. So this 30 scale boundary anno is probably what would actually get used on the site plan, because we're not going to show this whole resolved boundary matrix on the site plan. That'll go on the ROS because I need to show that to the county surveyor and the retracing surveyors. But but that's not going to be needed for the site plan. So we would probably use this 30 scale ano on the actual site plan. So that's how this works for boundary surveys, and we use a similar set of principles for our topographic mapping. So I'm going to go ahead and stop this section now of the workshop. When we come back in the next section, we'll look a little bit at the diagram for how we organize our drawings for topographic mapping. In this section of the workshop, we're going to go ahead and look at the topographic mapping example. And so I have a diagram here, and then we'll jump over into CAD, and I'll quickly show you how those drawings look. I'm a little bit worried that I'm going to run out of time, so we won't spend as much time as we did with the boundary drawings, but I will let you take a look at those in CAD. So the way this system works, again, we're applying that base system to a separate type of mapping product here, right? So we have typically on a topo workflow, we have a couple support drawings. So we do a drawing that has our actual surface entity, the break lines and the points, and the surface entity, which at our shop is in Carlson Survey. And then we also have a drawing with our topo points in it. Neither one of these end up in the drawing that produces the mapping deliverables. This topo points drawing is typically the labels for the points and the symbols are shown at a very small scale. So typically like 1 inch equals 1 foot, or maybe 1 inch equals 2 foot, just so we can see the points and the densely packed points. So it's not made to be for display in a mapping product. That's why it's a support drawing. Then, similar to a boundary drawing, we have a topo line work drawing, so that just has the line work in it, no annotations. We have an ano drawing at whatever our main scale is. Now, in the topo, we do have a couple extra drawings. Remember, I told you as you develop this system for particular working products, you'll do this. So these are base drawings, but we have some extra base drawings in a topo that we don't have in a boundary. So we separate out our hatch. And the reason we do that is two reasons. Is hatch is scale dependent, and we typically want hatch at the bottom of the display order, and so it just works easier if it's kept in a separate drawing. We also separate our contours. Again, we do that because the contours are typically towards the bottom of the display order, so we usually have our hatch at the very back and then our contours. And these are usually screened, so they're kind of a grayscale. Then we have a separate drawing with our spot elevations. Now, we do those in Carlson, and they're actually point objects, Carlson point objects, but they're like an annotation because they have a symbol and they have a multi-liter label. So they're almost like another ano drawing, and they are scale dependent. We keep those in a separate drawing. And then almost always when we're doing a topo, we don't typically lay out topo sheets. Because most of the time we're trying to encourage our architects and civils to work with just a drawn deliverable, and so we put together what I call a master drawing, and I'll show you an example of one here in a minute. Now we do still have some old school clients that want PDF sheets of the topo, which is okay, but we charge for that. So if you want, at my shop, a topo deliverable with a master drawing is less expensive than a topo with sheets, because there's a cost to setting up and laying out the sheets. So this is how the basic CAD system is applied to topographic mapping. And so let's take a quick look at that. So here is a topo folder. This just happens to be another job I did near Sacramento. It's just a coincidence, but here's the topo folder, and you can see those drawings I talked about are in here. So contours, spots, the surface drawing, the ano, the hatch, the line work, and the topo master. So let's see what those look like in CAD. So here's the line work drawing. This is a small commercial site that was purchased, and the client was going to do a fairly significant remodel and some site improvements. So this is the line work drawing. This is the existing structure, and there's some concrete here, and this is the public street, and this is the fence. Okay, here's the topo ano. So there was a lot of tree cover on this site. So this is the topo anno, but you can see we're calling out some features here with some elevations, and we have some block symbols for the trees and for some of the utilities out on the street. No lines in this, just annotations. And then we have, this is the hatch drawing. So this is just the hatch, the pavement hatch, the concrete hatch, and the building hatch. And so what do we get when we put all these together in a topo master? We get something that looks like this. So here's the topo master drawing. It looks like on this we actually also XREF'd in, we called it the skinny boundary drawing. And so that was something the client asked for on this that we don't normally do. But they said, hey, we just want the subject parcel boundary just with some bearings and distances. We don't care measured record. We don't care. We don't need tie lines. So that's we did a skinny boundary drawing on this for the client. But you can see those are XREFs, and so that's important to remember, because as we make changes, if we were to go in and make changes, we want those to waterfall. And you can see we got our contours in here too. Now, what we do in a topo master, you got to remember, if we're shipping a boundary master or topo master, the client usually isn't getting a PDF deliverable, and I'm okay with that. So what we normally do is we go in and we'll add notes at some reasonable scale, the type of notes that we would have on a sheet. We've got our north arrow scale. I have our standard topo notes are in here. So this is a topo master. Again, there's nothing in model space except for the XREFs and these notes. That's it. That's all that's in model space. So that's how a topo master drawing works. All right, so let me move to the next section. So we're going to just jump right into that. Let me check my outline real quick here and make sure I'm not skipping anything on the topo. Okay, so I want to talk a little bit about the folder structure that we use. So let me cruise over to our templates. And we can talk a little bit. I'm not going to walk through this whole folder tree, but I will show you the CAD folders. And again, you can set this up you set this up however you want, whatever works the best for your organization. But let me just walk you through these top level folders. So our base drawings for our typical project only go in two folders. So they're going to go in either the boundary folder or the mapping folder. That's the only two places those go. Support drawings will typically go in we have a Carlson folder. At your shop it might be a Civil 3D folder, but at our shop, that's where the support drawings typically go. With an exception, we do, under the topo folder, we keep we will have for those jobs that need a surface, we will have a surface folder in here that has the surface drawings. So base drawings go in topo and boundary. Support drawings will typically go in the Carlson folder, and then all of the sheet drawings and or master drawings, you got to remember, master drawing is like a digital sheet drawing with no paper edge. Those always go in the mapping folder, and then we have a subfolder for each particular mapping deliverable. Gets its own subfolder in here. So that's how we've organized our job to support this system. And I think you could use you could do that in a lot of different ways. You could still use this system and just have one folder called CAD if you want, that had all your drawing files in it. That would still work. But I just wanted to show you guys that's how we set this system up to work. So that was pretty quick. It was fairly simple, but that part of this system is pretty simple and it works pretty good. You can see we've got a utilities folder. So if we're doing utility mapping, there would be utility drawings in there. If we're doing a site plan, there might be some drawings in the land use folder as well. Or if we're doing flood stuff, there might be drawings in the flood folder. Okay, so the next thing I wanted to do was talk about some drawbacks of this system. So let me back up here. And I'll pull a couple more slides up. So there are some drawbacks to this system, so let's talk about those. I'm going to pull up my outline here so I don't miss anything. So this system is not perfect. and there are some trade-offs, right? Now I talked about in the beginning of the workshop some of the things that I think are advantages, right? So just the big two are in the title, right? Reuse and parallel work. Okay, but there are other things. There are other benefits to this besides that, right? So it reduces errors, saves time and money, makes training easier, allows you to more fully utilize your technical people. Hopefully it makes you more profitable. So those are all advantages. But there are some disadvantages or some drawbacks. So I want to talk about those. There's probably more than I have listed here, but I'm going to hit my big three. So in this system, you are going to have more drawing files. There's just no way around that, right? Because what you're doing is you're separating out each main theme or element. I suppose that comes from my GIS background. So you're separating out each theme or each element into its own drawing. So there's just more drawings to manage, period. There's just no way around that. That can certainly be a disadvantage. The other thing is, in order for this system to work, your people have to be really good at working with XREFs, which isn't a huge deal. I think it's fairly easy to learn, but you got to have some XREF ninjas on your team because it's a system that is very dependent on XREFs. And I don't care what CAD software you're using. XREFs just tend to be a little more buggy. Now, we don't have a huge amount of XREFs in each of our drawings. Somewhere between 6 and 8 is probably the most. And as a general rule, we are not nesting XREFs either. But as you increase the number of XREFs and start to nest XREFs, things get buggy and CAD can crash more often. And sometimes you gotta train your people to understand how layer controls work with XREFs. There are some environment variables that control how if you change the layer in an XREF, does it show up in the host drawing? There's some environment variables you need to understand there. I have some videos on my YouTube channel. The Redefine Horizons YouTube channel, the learning channel, has some videos about that. That talks about that. So you got to be good with XREFs. And XREFs can be a little more buggy than the bucket method, where everything's in one drawing. So that is a potential disadvantage. And then the other thing is, it can get a little tricky with your annotations because we're trying to share annotations between work products. And so sometimes you have to have some workarounds to make that happen. So what are the workarounds? Sometimes you might have a label that you move a label so that it shows up in the right place in a couple different deliverable drawings, whereas maybe if it was in a single deliverable, just for visual appeal, it might be in a slightly different place. So you might have for example, like a parcel label that you move to be a little bit off center so that it doesn't overlap with labels in another deliverable drawing. So that sometimes, I don't know that it's a huge deal, but it might be something you could notice if you look super close at our work products and we're being super nitpicky. The other thing is, to make this work, sometimes you have to use some wipeouts in your sheet drawings so that if there's labels that you don't want to see, maybe so our anno drawings tend to be fairly seamless. So if you have a sheet drawing and it's cutting off some labels, you might have to wipe those out in the model space of your sheet drawing so that you don't get labels that are cut off. And then the other thing is, we do not use annotative text here. So if you're a huge fan of annotative text, there might be some challenges with this system. I hate annotative text, probably because I'm old. It's clunky and causes problems. So we don't use it here because I got to make that call 5 years ago when we started. So we don't use annotative text entities. If you're highly dependent on annotative text, that might irritate you. I think you could get this system to work. What would happen is you would have a single annotation drawing with your annotative text at multiple scales in one drawing, but that's not the way we do it. The other thing that we do, which is probably a little less common, is we actually, most of the time in our anno drawings on a frozen layer, or as a separate drawing, we will have our viewport footprints from our sheets in a model space drawing. We just call them viewport footprints that we can quickly XREF into our anno drawings so that we can position our labels properly so they're not being cut off by the edges of sheets. And so, it takes some getting used to that, and that it's a little extra effort to maintain an up-to-date drawing with your viewport footprints. But those are the big three. There's more drawings. XREFs can, get a little buggy. You got to have some XREF ninjas, and annotations can be a little tricky. You might have to get accustomed to some hacks or some workarounds to get that to work. So, all right, that's going to wrap up this section of the workshop. I'm going to see how I'm doing on time, and if I have time, we'll wrap up with just some tips for if you thought you might want to explore or implement a system like this, some things that could help you. All right, guys, we're wrapping up. If you stayed with me this whole almost hour and 15 minutes, I appreciate you. Hopefully I didn't have you snoring. So anyways, thank you for sitting in and watching the workshop today. I did have a little bit of time left, so I wanted to just close with a section, just a few minutes of some tips for implementation. So the first thing I would tell you is don't feel like you have to copy this system in its entirety. You can this system can be partially copied. You can take some of the parts that you like. You don't have to take the whole thing. And certainly, I think it's broadly applicable, not just to different types of mapping, but just to all kinds of different deliverables, professional deliverables that are prepared in CAD. And I would also tell you that, I think this system maps onto different file folder structures pretty well, and it can map to your organization's workflows fairly well. So it's pretty flexible. And if you stick to the key principles, I think you can see some benefit, even if your particular implementation of this or flavor of this is significantly different from what we've covered in the workshop. So don't be afraid to just take parts of this or to create your own flavor, because I think that's how the system is designed. And so when you think about what are the key elements of the system, right? The key elements are separating your base drawings from your deliverables, from your deliverable drawings, right? And separating your mapping deliverables into single sheets instead of having all it's anything that moves you away from the bucket method of the bucket method CAD system, where all your stuff is in one drawing. And I didn't talk about this at the beginning of the workshop because I didn't know how much time I've had, but I've seen that bucket method bite surveyors multiple times. And I was working with a small to mid-sized civil engineering firm a few years ago, and they had a drawing. They were doing some land development, and they were doing a residential development that had some single-family homes and some townhomes, and they used the bucket method. So you had to go into their drawing with so they had a drawing. It had all the sheets for the subdivision map, and then the actual authoritative line work for the new lots lived in that drawing. And what happened is, at some point the project got phased, and there was a change to the line work, the design, the lot layout, and the line work got changed in one of those phase drawings, but it didn't get changed in the other one, and it created a big problem. So if you don't have one authoritative source for your line work, that's what can happen, right? That's one of the things I really don't like about the bucket method. And I was talking to a friend of mine that's a surveyor that works for a civil survey firm, and one of the things that he gets frustrated about on a fairly regular basis is somebody makes a design change. You got to remember, he's working with the civil team. Somebody makes a design change, and that change doesn't ripple through to all the drawings that need to get updated, and then something gets laid out or staked in the field that doesn't reflect the current design. So this kind of system is made to prevent those problems. So it'll work. It can work for construction too, for construction surveying as well. So it's broadly applicable. So remember the principles. You've got your base drawings; they're the authoritative source. You've got your support drawings; they don't go in the deliverable. Then you have your sheet drawings, and if you're not doing a deliverable with like PDF sheets, then you have what's called a master drawing. So those principles are broadly applicable. So what are if I've inspired you, that sounds extremely arrogant and haughty, but if maybe inspire is the wrong word. If I've intrigued you and you think I want to think about how I might do this at my own organization, public or private, what can you do? So take small steps, right? I talked about this in my other workshop on Field to Finish. Take baby steps. You don't have to do this all at once. You could start with something super simple like just having a line work drawing that gets XREF'd into the bucket drawing, right? So just pull out your line work to start maybe. So you can take small steps, or maybe you implement the whole process, but you do it on one project, or you do it with one small team inside your organization. So there are ways to do this, baby steps, and I think you should do that. I don't think you should you shouldn't roll this system out across a 250 person design firm tomorrow. Don't do that without some testing it with some smaller pilots. So take small steps. The other important thing, and I know we as managers and leaders don't always do a good job of this, is involve your folks. Have them watch the workshop, talk to them about what this might look like at your organization. I think surprisingly, you might have less pushback on something like this than you will on Field to Finish, because you're not dealing with crusty old party chiefs like me. But you could potentially have some pushback from other people in your organization, your design team or your CAD manager or your IT folks. So everybody, you gotta communicate what you think the benefits are. Be honest about the drawbacks. We talked about those, right? That's why I put that in the workshop, and make sure you got people on board before you do this. So get buy-in from your folks. Get them to help you design the system. The other thing I would tell you is if you're not 100% sure how to do this, so maybe you watch the workshop but you don't do topo or boundary mapping, and you're like, Landon, I only do flood mapping, or I only do utility mapping, and I have no idea where to start. All right, well, you can call me. My number is freely available on the internet, my cell phone number. You can call me or text me or email me, or just give Redefined Horizons a call or an email. But the other thing I would tell you, if you don't want to talk to me, maybe find me extremely annoying, is start with your deliverables and work backwards. So take a PDF deliverable from your last project and ask yourself, what are the elements of this deliverable, and how can I separate those out to use the system, the kind of system that Landon talked about in the workshop. So start with your deliverable and work backwards. That's a really good tip. By the way, all these tips are also that I tell people when I'm helping them design and implement a GIS system. All these same principles apply, right? Take small steps, involve your people, and then start with your deliverables and work backwards. The other thing is, don't forget about that principle we talked about at the beginning, right? Dry. Don't repeat yourself, right? So you don't want, one of the keys to this system is to not have multiple copies of the data, the actual drawing data. You don't want copies. You don't want them in more than one place, unless you're archiving something that's been sent to a client, right? So I'm not talking about something that a snapshot or a freeze or something that goes into an archive, but you don't want more than one copy of an annotation drawing or a line work drawing that could potentially go into a deliverable. There should always be one authoritative version. Don't repeat yourself. That's the dry principle. And then as you're going to develop your system, just remember you're trying to focus on reuse and parallel work. That's the whole benefit of this system. It's the two main benefits. So I talked about this in my Field to Finish workshop. If you don't need that, if you're not worried about reuse, and you don't care about having the ability to have your multiple people work on the same set of drawings for a job at the same time, then this might not be worth the drawbacks, right? And so it's gonna be applicable to different types of companies. If you're 5 years from retirement or 3 years from retirement, and you're gonna sell your business to the highest bidder and retire on the beach, then it may not be worth the effort to do this, because it does involve some work. But I think there are a lot of benefits there, especially if you want the ability to speed up your time to delivery to the client, which clients care about more than just the price, right? They also care about time to delivery. A lot of clients do. So there's good opportunities here to reduce errors and speed time to delivery, more fully utilize your staff. So focus on that. As you go to design the system, think to yourself, if I were to have 3 or 4 of my best survey techs or CAD techs, mappers working on this job at the same time, how would we structure the data, the drawings to facilitate that in a way, in such a way that people weren't walking all over each other? I haven't had time to talk about it, and I won't go into detail, but one of the things I've been thinking about more is how we can use a version control system like Subversion or GitHub, Git, or similar version control system from the programming world to help us do things like version our drawings and further facilitate this parallel work. So I've got a couple videos on our Redefine Horizons YouTube learning channel you can check out if you're interested in that. So focus on those principles, reuse parallel work, and then don't strive for perfection. Our system is not perfect, and it will probably be a work in progress until I retire or die, and then after I'm gone, I hope Redefine Horizons continues, and the folks that take over will still be working on how to improve this system. Just because it's a complex system, what we do is hard, it's not easy, technology changes, you do different types of projects with different people. So there's always room to improve. So don't worry about it if it's not perfect. Our system's not perfect. I saw some things tonight when I was nosing around those couple example projects I showed you that I was like, yeah, we should clean that up. We should think about how we do that. So it's okay. Doesn't have to be perfect to be an improvement. So, all right. I really appreciate you guys catching the workshop. I know I'm close to being out of time. So thank you. I hope you guys got some value out of this and that you enjoyed it and I didn't put you to sleep. I appreciate you being patient with my home office and my little bit of a scratchy throat. So thank you.